So we're trying to find the radius of convergence of the following power series. And what we do is we first apply the ratio test, so the limit as n goes to infinity, of, just as a reminder, a sub n plus 1 over a sub n, the absolute value of that. And so setting this up, basically what we end up doing is a sub n plus 1 times the reciprocal of a sub n as a bit of a shortcut. So limit as n goes to infinity. Let's start with a sub n plus 1. So that'll be 2 times n plus 1 factorial x to the n plus 1 over n plus 1 factorial squared. And we really need to pay attention to our parentheses and where the plus 1 goes. Now times the reciprocal of our original, n factorial squared over 2n factorial x to the n. Okay, now we'll do a little bit of rearranging and then we're going to do the rest will be algebra. So here, this will be, let's put in our limit as n goes to infinity. 2n plus 2 factorial. This one I'm just going to write as n plus 1 factorial. We can rewrite as n plus 1 times n factorial squared. So I'm rewriting the n plus 1 factorial there. Maybe hard to read. That's a factorial symbol. And here we've got n factorial squared 2n factorial x to the n. Now let's start to see what kind of expansions and canceling we can do. So with factorials, what we're going to want to do is write those out as much as possible. So 2n, or at least until we see a cancel. So 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. Now we see that our cancel there. Here I'm going to distribute the square. So I have an n plus 1 squared and an n factorial squared. And we see another cancel. And somewhere along the lines I lost my x to the n plus 1 here. And I'm about to lose it again here. X to the n times x. So I'm going to rewrite that x to the n plus 1 as x to the n times x. N factorial squared over 2n factorial x to the n. So we can start doing some canceling. The x to the n's are going to cancel. The n factorial squareds are going to cancel, and the 2n factorials are going to cancel. The next thing we'll do is we'll pull out anything that doesn't depend on n, which in this case is just this x. And I'm going to write it out in front of the limit. So the absolute value of x, limit as n goes to infinity. I no longer need the absolute value here because this is all going to be positive. On top, I've got 2n plus 2 times 2n plus 1 over n plus 1, the quantity squared. So I've got the absolute value of x. Now this limit, we're going to have a quadratic over a quadratic, and we'll be able to show really quickly with L'Hopital's rule that this limit is just going to be 4. Now what we want is for this to be less than 1 in order for this to converge. So in solving this, what we get is that the absolute value of x has to be less than 1/4. So what we've got in this 1/4 is our radius of convergence. And that completes this problem.